না না পয়সা হয়েছিল এখন না, আমি বাড়িতে গেছি আর। নিচে ফেলা দেওয়া বলে।
ক্যামেরাটি কি শোনা যাচ্ছে? সরি, অডিওটা কি শোনা যাচ্ছে? অডিও কি শোনা যাচ্ছে আমার? একটু নয়েজ হচ্ছে। এখন বেটার? ওকে, ফ্যান এখন অফ। Yes, that's better. ওকে, ক্যামেরা অ্যাঙ্গেলটা কি ঠিক আছে? হোয়াটস নট ক্লিয়ার? মানে ক্যামেরা অ্যাঙ্গেলটা ঠিক করতে হবে নাকি ডিফারেন্ট স্টাফ? ল্যান্ডস্কেপ হলে অনেকের আবার প্রবলেম হয়, মানে I don't know, অনেকের মেবি ল্যাপটপে দেখতে সমস্যা হয়। That's the complaint I heard last time. I think we'll wait a bit and start in 5 minutes. Okay, we have around 30 viewers. I think it's good enough to start. ল্যান্ডস্কেপ করলে সমস্যা হচ্ছে যে অনেকে ল্যাপটপ ইউজাররা দেখতে পাচ্ছে না। Okay, let's start. Last time আমরা দেখছিলাম any object which has the Schwarzschild radius, যেটাকে কম্প্রেস করা হয়েছে to Schwarzschild radius, is a black hole. মানে তার একটা Schwarzschild radius which is if I remember correctly, যদি ওইভাবে কম্প্রেস করা হয় একটা অবজেক্টকে এই রেডিয়াসে, এটা হচ্ছে তার মাস, we call that a black hole. And we learned that যে black hole সব পুরা mass is concentrated at the center or r equal to 0. মানে একটা স্টার কোলাপস করে ব্ল্যাক হোল ফর্ম করতে পারে, এনিথিং ক্যান কোলাপস and form a black hole. So আজকে আমরা দেখব what the black hole, a famous problem in physics, information paradox. Okay. So we first need to know what information really is. Information. Let's go step by step. Everything, okay, information, this could be, in physics we sometimes use the term quantum information. We just like to put everything, quantum in front of everything. Maybe quantum bottles someday, anything. So information just stands for quantum information. Everything that exists in the universe, information. By everything, I mean you, me, molecules, atoms, everything is information. Glass, paper, everything we see around is information or quantum information. And an important fact about quantum information is information can never be destroyed. Now what does that mean? You can surely point out যে মানুষ মারা যেতে পারে বা একটা পেপারকে বার্ন করলে তার ইনফরমেশনটা তো চলে যায়, রাইট? সো টু দ্যাট পেপার বার্ন করলে ইনফরমেশন নট নেসেসারিলি বেসিক্যালি কিছু করলেই নো প্রসেস ক্যান ডিস্ট্রয় কোয়ান্টাম ইনফরমেশন। ফর এক্সাম্পল যদি পেপার বার্ন করি কি হয়? উই বার্ন ইট, আগুন ধরে, সাম অফ ইট ইজ রেডিয়েটেড অ্যাওয়ে, রেডিয়েশন বের হয় আগুনের, অ্যান্ড কিছু কিছু অ্যাশ হিসেবে পড়ে যায়। দ্য ইনফরমেশন ইজ নট ডিস্ট্রয়, জাস্ট রেডিয়েশন হিসেবে চলে গেছে কিছু আগুন পুরানোর ফলে, আর কিছু অ্যাশ হয়ে পড়ে আছে। সো দ্যাট ইজ যে ইনফরমেশন ডিস্ট্রয়েড হয় না, জাস্ট অন্য ফর্মে চলে গেছে। ইটস এ সিমিলার এনার্জি অ্যানালগ। নো অ্যামাউন্ট অফ ইনফরমেশন ইজ লস। মেবি আমাদের ওই পেপার বার্ন করার ফলে যে ইনফরমেশনটা আছে ওটা রিড করতে কষ্ট হবে, বাট থিওরিটিক্যালি ইটস পসিবল ইউ ক্যান রিড দ্য ইনফরমেশন যেটা বার্ন হয়ে গেছে। ওখান থেকে পেপারটা কেমন ছিল, তারপর মেবি পেপারের কোয়ালিটিস কী ছিল, কর্ণফুলি পেপার অর এনিথিং, ওখান থেকে আমরা ইনফরমেশন বের করতে পারবো যে এটা কীরকম পেপার ছিল। This is what quantum information actually is. It's everything. Information is everything. So now, to understand the black hole information paradox, we need to understand some basic concepts of a theory which we call I hope the idea of information is really clear. First, we need to understand some basic concepts of quantum field theory. I'll call it QFT. And about QFT is the most experimentally verified theory out there. It explains there are four basic forces. The strong nuclear force, the weak force, and electromagnetism, which we see every day, and of course gravity. It can explain three of them, of course, except gravity. And by explain, I mean everything. It can explain from your movement to everything, every single thing in the universe, except gravity. Every phenomena in which gravity isn't involved. It can explain everything except gravity. Okay. So, now what's the basic idea of quantum field theory or QFT? I'll probably give three basic ideas. It's absolutely weird and I don't know I have lost words for it. Okay, so what do we know? What are the most fundamental building blocks of nature? Atoms. You can break them. You can break atoms. You can make electrons, and you have a nucleus. There is protons, neutrons, and so on. You can basically break protons and neutrons as well. Let's suppose they are the most fundamental particles. But excuse me for a second. What quantum field theory says fundamental building blocks of nature aren't particles but something which we call fields. And now what does that mean? I will answer all questions at the end of the class, so if you have questions you can just write it up because you might forget that, but I'll answer in the last 10 or 20 minutes. So what does fields mean? It's sort of like a fluid-like substance spread throughout the universe. And what does that mean? Fluid. It's sort of, think of it like a wavy substance. A wavy substance spread throughout the universe. That is a basic idea of fields. We see one of the examples of fields every day. For example, if you have all of us have seen magnets. For example, this thing, this attraction is due to the presence of magnets. This is due to the presence of magnetic fields. We have experienced magnetic fields and electric fields. They are the basic example of fields. Magnetic fields are something special that pulls North Pole towards the North Pole and the South Pole towards the South Pole. It just attracts the poles, and these are due to something called fields. It's an abstract concept. It's sort of like a fluid spread throughout the universe. Even everywhere in the room you're sitting, there's spread something called the electron field. It's like a fluid, fills the entire universe, and the ripples, the wave, think of water waves, the ripples, the hail of this electron fluid gets tied up into bundles of energy that we call electron. Let's think of it like this. Fields is just, we just like to give it a wavy representation. Fields, and due to some phenomena, the fields get bundled up and they form particles. So the fundamental, according to quantum field theory, the most tested theory and most experimentally verified, the fundamental building blocks of nature aren't particles but fields. And the excitation of fields, or the bundling up of fields, jora lagano, they give rise to particles. And particles make up us. So the most basic building block of nature are fields. Is everybody okay with fields? If not, I can repeat. So you can ask anything if you want me to repeat the idea of fields. Okay, so let's move on. So this is the basic idea of quantum field theory. There's another idea that QFT says every particle in the universe has an antiparticle, and this thing is also experimentally proved. Every particle in the universe, there is an antiparticle for it. Let's see an example. For an electron, it has a negative charge. This is an electron. It has an anti-partner called the positron, which has a positive charge and just same characters, the same mass, everything. So when an electron and a positron. So every particle has an antiparticle, same mass, same everything, just the opposite charge, and the property that when they come together, they create energy. That's the second idea of quantum field theory that we need for understanding the black hole information paradox. Okay, so the next, there is another idea. We'll use three ideas of quantum field theory. One, fundamental building blocks of nature aren't particles but fields. The second one, every particle has an antiparticle. And the third one, idea everywhere around us particles and antiparticles are produced and destroyed every moment. Now, what does that mean? This means everywhere around us, say for example in vacuum, in a distant planet, in a place where there is no planet, anything, kichu nai, okhaneo pairs are being produced. Pair produced bolte ki hocche? এরকম ইলেকট্রন আর পজিট্রনের মতো পেয়ারস প্রডিউস হচ্ছে, এরকম পেয়ার প্রডিউস হচ্ছে এন্ড সাথে সাথে এনার্জি হয়ে যাচ্ছে এভরি মোমেন্ট। ইটস আ স্পন্টেনিয়াস প্রসেস। প্রডিউস হচ্ছে, এনার্জি হচ্ছে, ওই এনার্জি থেকে আবার প্রডিউস হচ্ছে এন্ড সো অন। Every second particles are being produced and destroyed. Even around you in this vacuum, in a place there is not even a planet or anything, the particles and antiparticles are being produced every second, every moment. So these are the three basic ideas we need for understanding the black hole information paradox. The first idea is the fundamental building blocks of nature aren't fields but particles, and universe has a particle and an antiparticle. The third, everywhere around us, particles and antiparticles are produced and destroyed every moment. These are the basic three ideas of quantum field theory that we need to understand. Okay, since we should be clear, someone asked, I couldn't understand first idea, can you repeat? The first idea says, what is the building block of nature? You'll say atoms. But quantum field theory says it's not atoms or it's the smallest particle, electron, not electrons, but something more fundamental, something called fields. This is the basic, most fundamental level. Think of them as a fluid spread throughout the universe. And this fluid and a fluidের excitation or bundling up, এরকম যেমন ছোট ছোট যদি বান্ডল ফর্ম করে তখন আমরা we get something called particles. This is the first idea. Think of it like a fluid spread throughout the universe. A fluid bolte water. Maybe think of water. Something like water, but not water, obviously, but something like water spread throughout the universe, everywhere, around me, around you, everywhere. Even in the room you're sitting, there's something called the electron field. A electron field excitation er karone, electron field যখন bundle up হয়ে যায় বা যখন close bundle form করে বা একসাথে চলে আসে কিছু জায়গায়, ওখানে আমরা particles পাই. Just think of it for now, just think of it like this. Achha, the next question, if you are a smart person, I'm not saying anyone isn't smart, but if you are a smart person, the next question to ask, a pair production to সবখানে হচ্ছে, right? What if this pair production occurs outside the event horizon of a black hole? কি হতে পারে? This is something Stephen Hawking is famous for. I tried to work on it under our final year thesis. So this is what it says. Let's say this is a black hole. It has mass, for example, it has mass m. This is a black hole. This is the event horizon. Event horizon is like a one-way ticket. It's like a place যেখানে ঢুকলে আর বেরোতে পারবে না. If something enters a black hole, you can get out of it. That's the place from where যে ঢুকলে আর বের হওয়া যাবে. Yeah, fields are kind of waves. Yeah, you can give it an interpretation of waves. Magnetic field, আমরা ছোটবেলায় magnetic lines of force পড়ছি, magnetic field, একটা ম্যাগনেটকে যেভাবে অ্যাট্রাক্ট করে, something like that. It's a magnetic, Faraday called it the magnetic lines of force. এরকম যে it's the basic concept why magnets attract each other, just because both of them produce something called the magnetic field, and magnetic field এর orientationের কারণে এই attractionটা হয়. Okay. Some of you have answered what I'm going to say now. So if you have a pair production outside a black hole, pair production ধরলাম not necessarily electron or positron, অন্য অনেক particle আছে quantum field theory তে, or more precisely standard, we call it the standard model of physics. So অনেক particles আছে, not necessarily electron positron, যে particle আছে তার একটা anti-particle আছে, আচ্ছা, let's say for example, let's consider electron and the positron pair production will outside a black hole. So now what happens? এই যে anti-particle আছে, it's from calculation, it's for reasons যেটা it's more mathematically rigorous. Just I need you to understand যেটা হচ্ছে, I need you to trust me here. The anti-particle falls inside the black hole and the particle is radiated away. That's a basic idea. And this radiated particle, it's a radiated particle is part of something we call the Hawking radiation. Okay, the antiparticle falls inside. So if the antiparticle falls inside, we know for sure there is matter inside the black hole. Matter made the particles, the star that collapsed to make a black hole is surely formed of matter. That we know for sure. So if that antimatter goes inside the black hole, কি হবে? এই antimatterটা sure আরেকটা pair পাবে, আরেকটা pair of matter পাবে. For example, it might get an electron. If this is an electron, আরেকটা electron পাবে, and ওই electronটাকে সে খেয়ে ফেলবে, খেয়ে এনার্জি প্রডিউস হবে. এই ইলেকট্রনটার কিন্তু ম্যাস আছে, এন্ড অ্যান্টাইপার্টিকেলের কিন্তু ম্যাস আছে. ব্ল্যাক হোলের ধরলাম এই ইলেকট্রন আর এদের ম্যাস হচ্ছে m. এই ইলেকট্রন, প্রোটন, ইলেকট্রন, পজিট্রন, যে কোন সবগুলোর ম্যাস হচ্ছে m. সো যদি m হয়, and this is m, big M, তাহলে ব্ল্যাক হোলের ম্যাস যদি অ্যানাইলেটেড হয়ে যায়, মানে ইলেকট্রন আর পজিট্রন মিলে এনার্জি ফর্ম করে, ব্ল্যাক হোলের ম্যাস কি? In a way decrease করবে. So if this is m, the black hole mass becomes এটা, decrease হবে. And as I said, okay, is this part clear? Oh, why anti-particle falls inside instead of particle? That's a more, I need you to trust me because that's a more mathematical concept. You just need to accept for now. Just এখনের জন্য মেনে নাও যে particle anti-particle মধ্যে anti-particle ভিতরে পড়ে. That I need you to accept. Okay. So যদি পড়ে, the original mass of the black hole was m, and it decreased by a small m. যদিও এটা খুব ছোট, মেবি 50,000 কেজি থেকে 10 to the power minus 27 কেজি কমছে, but there is another catch. আমি কিন্তু বলছিলাম in everywhere in the universe particles and anti-particles are being produced, মানে spontaneously পুরা ব্ল্যাক হোলের হরাইজনের বাইরে পেয়ার প্রোডাকশন হইতে থাকবে and black হোলের mass will continue to decrease. একদম ডিক্রিজ হইতে অনেক কমে যাবে, and at one point the black hole will be gone. There will be nothing. So this is acha, is everybody okay with it? Yeah, black hole, they die, they just evaporate away. সব এনার্জি শেষ হয়ে যায়। আচ্ছা, এখন next obvious question, there are many problems with the black hole. This is the black hole information paradox. Oh no, not this, just okay, let me build up on it. This is the problem Hawking pointed out in 1975. This might happen outside a black hole. 74 or 75, I'm not sure about that. Probably 75. Okay. Now, let's look at in terms of information. Information er basis e dekhi. Black hole, we have a pair production. Let's look at it in terms of quantum information. So যদি একটা পড়ে যায়, এটা চলে গেল। Okay, let's say for example এই পার্টিকেলটার information আছে about this one. Let's consider for now. But black হোলের ভিতর কি হচ্ছে, যে এটা জিনিসটাই যাচ্ছে ওটা তো destroyed হয়ে যাচ্ছে, কারণ we know that nothing can come out of a black hole. So black হোলের ভিতরে যে ইনফরমেশনটা, যে পার্টিকেলটা পড়তেছে, that is essentially gone forever. And this one, ধরলাম this one has information about this one, but যদি ইনফরমেশনও থাকে, ব্ল্যাক হোলের ম্যাসও তো লুজ হচ্ছে। সো ব্ল্যাক হোলের ইনফরমেশনটা কই যাচ্ছে? আমরা জানি কোয়ান্টাম ইনফরমেশন ক্যান নেভার বি ডিস্ট্রয়েড। This is the famous information paradox. Okay, I have some questions. I'll answer them at the end of. I'm nearing by end. Okay, so this is the information paradox because আমরা জানি information destroy হতে পারবে না, but black হোলের ভিতর certainly there is this information gap. Even if this particle has information about this one, black হোলের ব্যাপারে তো information নাই। mass কমতেছে, energy lose করতেছে, আস্তে আস্তে black হোলটা ছোট হতে one day it vanishes. It's just gone. So there is certainly a loss of information in this scenario. This is the black hole information paradox. It's unsolved since there is some solutions. I can talk about the solutions, but these are very complex solutions and widely accepted. Amar jana mote widely accepted orokom solutions nai. So there is that. Okay, so this is where I end, and if you have any questions, you have a lot of questions, I'll answer them now. I hope everybody is clear with this information paradox issue. Pair production হচ্ছে black hole, ইয়ার বাইরে, horizon-এর বাইরে, and we have the issue of information paradox. So if you have questions, you can ask me here. If you want, you can email me. If you want to discuss anything about physics, you can email me as well. Email here. I'll try to answer if I can. And I would like to end the talk, and I would like to thank Bark for giving me this opportunity to explain in simple terms. It's been a challenge because we usually deal with the mathematics and we try to understand what happens, but এরকম ভাবে general public at least আমি ওভাবে চেষ্টা করিনি. This is my first time, so I hope you guys enjoyed it, and thank you. So I'll try to answer questions now. Okay. Angular momentum of a black hole. That's আমি কথা বলছিলাম Schwarzschild black hole এর ব্যাপারে. There is another black hole called the Kerr-Neumann black hole. It's a charged and spinning black hole. মানে আর্থের মতো স্পিনও করে and it's charged. So yeah, that is basically the rotating black hole. What's the geometry of the bundling up of fields in case of antiparticles? It's the same. The antiparticles are the same, just they constitute a different field. For example, if this is a field of electrons, that's a field of positrons. Everything is the same except the charge, and except the charge. They have similar what do I call it? Similar quantum numbers. If you are familiar with quantum numbers, they have the similar quantum numbers. Oyan Rahman Khan has asked a very good question. Why particle is much more than antiparticles? Yes, there's something called the, let's erase some of the things. Let's see what I can erase. It's something called the baryon asymmetry problem. I'm not sure of the spelling. Asymmetry problem. It's a problem dedicated to why there are more matter in the universe than antimatters. Because usually আমরা antimatters দেখি না কিন্তু only in particle colliders, but matter দিয়েই form হয় কিন্তু. Just matter is what constitutes us, you, me, everyone. Everything around us is composed of matter. That's an unsolved problem in physics. Okay, are particles and antiparticles in an equilibrium state in the QFT, or they're interacting, getting destroyed and forming again? In a vacuum, it's to say in a vacuum, particles and antiparticles are spontaneously being produced and destroyed. Destroyed in the sense they give rise to energy. Okay, why antiparticle falls inside a black hole? The mathematics is rigorous. If you want, you can look into if you have a necessary physics background, you can look into a lecture note of someone called Ted Jacobson. He explains, if you have a necessary background of physics, maybe you understand GR or general relativity and classical mechanics, you can look into his paper. He explains why an antimatter, why the antimatter should fall into a black hole. Hawking radiation is also one of the reasons black hole starts to lose mass and energy, and at one time, like trillions of years later, they die, right? Yeah. Well, we hope they die, because there are solutions which says they live on in Planck scale or in small, but that's not widely accepted. As far as I know, I think they just go off. They just go to nothing. Isn't positron an anti-particle of electron? Then isn't it possible? It's possible that one of them falls inside, because the eto strong gravity, but it's, as far as I know, the anti-particle should fall into a black hole. That's what I know. That should be the case. The particle with the negative energy should fall into the black hole. This one. We know radiation. We know radiation is absorbed by a black hole. So in event horizon, if radiation is produced, it should be absorbed. Please explain this. That's a very good question. Shahed Munir. So if you have a pair production, I assume you're familiar with quantum mechanics. So quantum mechanics says all particles are waves. So you don't need to be familiar with quantum mechanics, but just know this: all particles are like waves. So that's why it's called a Hawking radiation. Okay, so when a pair production occurs near a black hole, due to conservation of momentum, it's a basic law. We study it in like class 8 or 9. It's due to conservation of momentum. If one particle falls in, এটার momentumটা এদিকে হবে। এটার momentum যদি এদিকে হয়, that should be that way. না হলে momentum conservation violated হবে। Every particle has, so then একটা particle black hole ছিল, আরেকটা particle, yeah, if particles can remain without their anti-particle. For example, I don't have theoretically there should be an anti-particle for me as well. Same structure, just the opposite charge. And if I ever meet him, I hope I don't, if I ever meet him, bishal boro energy blast hobe. It's like a bomb blast, and it might destroy the universe as well. Just that amount of energy. Could you tell the solution of the paradox shortly? That there is no accepted solutions, but there are a lot of solutions. Widely accepted কোনোটা ওইভাবে না। এখন প্রেজেন্ট, আমি এটা বলতে পারি প্রেজেন্ট রিসার্চ অ্যারেনা কোন দিকে। আমরা প্রেজেন্ট রিসার্চে উই আর ট্রাইং টু কনস্ট্রাক্ট, আমি এটাতে একটু চেষ্টা করতেছি কাজ করা, ওটা হচ্ছে আমরা ইন্টেরিয়রটা কনস্ট্রাকশন চেষ্টা করতেছি। ব্ল্যাক হোলের ইন্টেরিয়র কি হবে ওটার ব্যাপারে যদি কিছু জানতে পারি, তাইলে আমরা মানে we can contribute to the knowledge of the development of interior. So ইন্টেরিয়রটা কেমন হইলে আমরা যদি বুঝতে পারি, কারণ কোনো no theory of physics, well, the experimental, no, I'm talking about QFT and GR can explain the interior of a black hole. So black hole interior যদি বুঝতে পারি, so I think we can understand more, we can know more about the paradox. আরেকটা solution হচ্ছে it's proposed by one of the famous physicists of our time, Lenny Susskind. So he says যে black hole কোনো information পড়লে that doesn't necessarily fall into the black hole, just horizon উপর থাকে. It's one of the solutions. It's called holographic principle. Some of you might have heard about it. It's a holographic প্রিন্সিপাল। এটা থেকেই অনেক প্রপোজাল আসছিল, সায়েন্স ফিকশন স্টোরিজ, যে উই লিভ ইন আ হলোগ্রাম, যে আমাদের ইউনিভার্সটা ইটস আ হলোগ্রাম, উই আর বিং কন্ট্রোলড, সামথিং লাইক দ্যাট। Is there a theory that information in a black hole are stored in binary and that anything that gets into it? Well, that's a very good question. Binary number. I haven't heard, not that I've heard about it, but এখন কিন্তু অনেক মানে ব্ল্যাক হোলের স্টাডি উই আর কোয়ান্টাম ইনফরমেশন দিয়ে হচ্ছে, দ্যাটস বেসিক্যালি ইনফরমেশন থিওরি। সো there are projects to explain the information paradox in terms of quantum bits. So jara CS major ase, they can look into it. Quantum bits, which we call qubits model দিয়ে অনেক explanation আছে, but not that I know যে ওইভাবে accepted, again widely accepted না। The black hole reduces X-ray and many other rays. So the information, okay, bhaiya comment box and mail address. Okay, I'll provide my mail address again. This is my mail address. Yeah, white holes are hypothetical, primordial black holes as well. Oh, Zohair Mahtab. Feynman says that attraction of a particle is for exchanging the boson virtual particle. So we don't need a quantum field theory. Well, the boson is the phenomena you are saying. That's because of quantum field theory. That's part of a theory we call the standard model. Standard model. We need quantum field theory in everyday life. It's the best one we have. It's still, there's string theory, but yeah, that's not experimentally proven, and not many theorists these days care about experiments like me. Can you explain the quantum definition of the negative energy approach virtual antiparticles? I'm not clear about your question. Okay, can you describe Hawking radiation shortly? Yeah, I surely can. Hawking radiation is a process where the particle falls into a black hole, and pair production এর কারণে the antiparticle radiated হয়ে যায়, and this radiation is called Hawking radiation. It's simple. It's a simple process. What is the radius of a black hole? Radius of a black hole, by radius I think you're talking about the Schwarzschild radius. This is the Schwarzschild radius, where m is the mass, g is the Newton's gravitational constant, and c is the speed of light, and it's squared. So it's also called the event horizon of a black hole. And is it expanded? Oh, again, we don't know about anything about the interior of a black hole. That's a portion of study. এখন মানে presently অনেক research হচ্ছে regarding what could be the interior of a black hole. So let's see if I missed anything. Okay, I guess we're done. I've answered. Oh, I'm missing another good question. One of the students asks, I was wondering to learn about Hawking radiation. He answered, he probably inboxed in the group, in the page or something. I was wondering to learn about Hawking radiation. What is it? So I kind of tried to explain what Hawking radiation is, but if you want to learn, you need to know GR and some basic quantum field theory, but not necessarily, it's better if you know it, but you can still study black holes. If you want to study it like us or like physicists, you can study. Bro, time dilation, is this even possible to stop time? I mean, what if I travel at the speed of light? It's a good question. Okay, we learned in HSC or something that mass increases or decreases. Well, if you're traveling at the speed of light, this is a stupid thing. Mass is a scalar, so mass doesn't change, but yeah, it's momentum that changes. Okay, so if you travel at the speed of light, yes, if you travel at the speed of light, time, but you can travel to travel at the speed of light, you have to be massless, like a photon. Like light is massless, light can travel at the speed of light. I mean, yeah, that's this. A photon can travel at the speed of light, if you put it in a better way. What is the concept of annihilation? Is the concept of annihilation hypothetical? No. And the electrons and positrons, they annihilate to give energy. It's, as far as I know, it's experimentally proven, because we have found the positron, right? The concept of antiparticles is proved probably in 1932 or something. I don't know the time, but yeah, in that region it was proved that antiparticles exist. The positron was found, so there are antiparticles. Yeah, so as time and space bends, okay, oh yeah, that's a concept of GR. So the bending of space and time, for example, how do I put it? Yeah, I made a blunder. Light can definitely travel at the speed of light. A photon can definitely travel at light speed. They're basically the same thing. I just made a blunder. Okay, so wait. I don't remember the thing, but let's see if I can remember. For example, this is a planet. This is another planet. Since space-time is bent, a light coming from here, যেমন কিভাবে example দিতে পারি? Okay, আমি ভুলভাল বলা থেকে just search Wikipedia for this. Just Google this, gravitational. I don't remember the actual procedure to explain lensing. Just Google for gravitational lensing. Okay, so I think I've tried to answer every question. Some of the questions wasn't clear, so tai pari nai, and my knowledge is limited. Of course, I just passed last year, so and I'm teaching at Prague, so I have no knowledge limited. Someday when I can, I will answer korbo. So if you want, you can email me. I'm email ta tao provide kore dibo. And thanks to Bark for letting me speak, and thank you for the opportunity. So yeah, thank you.